Okay, we are going to now look at the Pythagorean theorem notes for day 2. This is on page 11. We are not going to go over 7 and 8, so we're going to move on straight to number 9. Okay, so it says, use the figure below to answer the following questions. Find the length of x in simplest radical form and to the nearest tenth. So the problem is x is not just one, it's not just one length, like just this length. It is this entire length. Okay, so we're going to have to use Pythagorean theorem a couple times. So if we look at our light blue triangle, I'm going to go ahead and I'm going to draw that off to the side. Okay, so at this point we have a right triangle. That means that we can use the Pythagorean theorem. We have 8 as our side length here, and we have 17 as our long length across from our 90-degree angle, which makes that our hypotenuse. 8 is a leg, and so is our unknown side. Since we already have an x in the equation, or in the problem, I'm going to go ahead and label that as a y. Okay, so we want to use Pythagorean theorem, and if we remember correctly from yesterday, Pythagorean theorem is a squared plus b squared equals c squared, with c being our hypotenuse. Okay, so we're going to go ahead and just put our a and b in. Now, it does not matter which one is a, which one is b, as long as they're both the legs. So we're going to say y squared plus 8 squared equals 17 squared. So from here, we want to just go ahead and do some math. So 8 squared is 64, and 17 squared is 289. We can solve for y squared by subtracting the 64 on both sides. That leaves us with y squared equals 225. Now, to get y completely by itself, we have to take the square root. So if we take the square root on both sides, the square root and the square cancel, which leaves us with y equals plus or minus 15. But since we're talking about a side length, we're going to say that y is equal to a positive 15. So this portion, just the light blue portion here, is 15. Okay, now we need to know what this green portion is. So we're going to use the Pythagorean theorem again with the smaller green triangle. Okay, so we know this is a right triangle. Since this is a 90, that means that this side is also 90 degrees, which makes this a right triangle. We have our 8, we have our 11, and we don't know, we're going to call this Z. We don't know what that other side is. Okay, it does not matter what you call it. I'm just coming up with a random letter, and we're going to call it Z. Okay, so at this point, we know that we have a leg here, and we have a hypotenuse here because it is across from that 90-degree angle, and it is our biggest side. So we're going to plug those into our equation. A squared plus b squared equals c squared. So 8 squared plus z squared equals 11 squared. Okay, we have 64 plus z squared equals 121. 11 squared is 121. We can subtract the 64 on both sides, which leaves us with z squared equals 57. Now, if you go and you take the square root of both sides, the square root of 57 actually does not break down at all. It does. It breaks down to, I think, 19 and 3. But those are both prime numbers, so it would end up being simplified already. So z is just the square root of 57. Okay, so I'm going to go ahead and put that in here. So that means that this x, the entire length of x, is going to be the 15 and the root 57. So you would have to add those together. So we're going to say 15 plus the square root of 57. Okay, that's our exact value because we have a radical in there. But if we want to know what our approximate value is, we can plug that into our calculator. So we can say the square root of 57 plus 15 is equal to approximately 22.5. Because I'm sorry, it says in the directions, which I should have read clearer, nearest hundredth. So that's 2 decimal places. So this would actually be 22.55. Okay, so that would be number 9. Moving on to number 10. So we have the legs of a right triangle are congruent. So that means congruent means that they are equal to each other. So if we have a right triangle, sorry, my son's going down for bed tonight and he's kind of cranky. So the legs of the right triangle are congruent, which means that these 2 legs need to be the same. And it says the hypotenuse is 7 root 2. Okay. And it says, what is the length of each leg? So we have our legs and we have our hypotenuse. So we can go ahead and we can put that into our Pythagorean theorem. We have a leg squared plus another leg squared is equal to 7 root 2 squared. So here we need to figure out how many x squareds do we have, and we have 2 x squareds. So we're going to say 2x squared is equal to, now we have to figure out what 7 root 2 times 7 root 2 is. So you need to take the 7 times the 7, so everything outside, and then you're going to multiply everything inside, so 2 times 2 is 4. The square root of 4 is 2, since it is a perfect square, so we have 49 times 2, which gives me 98. So we have 2x squared is equal to 98. At this point, we can divide that 2 away, and we get x squared is equal to 49. Our last step is always taking that square root on both sides, which gives the square root away, and it takes that square away. And the square root of 49 is 7. So that means that each of our side lengths are equal to 7. And since we are given units, we're given inches, we can say 7 inches. Okay. Now with number 11, we have a square, which I'm sorry if my drawing is going to be a little off, but we should know that a square has all congruent sides. And this square, it tells us, has a diagonal, so that means from corner to corner. It has a diagonal of 14 inches. Okay, and it wants us to find the length of the sides of the square in simplest radical form, and then to the nearest hundredth as well. So we kind of talked about this already. We know that a square has all congruent sides. So if I know one side's x, that means every other side is x as well. And with a square, we should know from like middle school probably that a square has all 90-degree angles, which means that this whole thing is a right triangle. So this is going to be really similar to number 10 now. If we break this apart and just look at the triangle, we have side lengths of x, and then we have a hypotenuse of 14. So this is going to look very similar, like I said, to number 10. So we can use Pythagorean theorem since it's a right triangle, and we can say that x squared plus x squared is equal to 14 squared. Again, we can combine these x squareds, and we have two of them. So we have 2x squared equals, and 14 squared is 196. At this point, we're going to, like I said, do the same thing we did in number 10 and divide by 2 on both sides, which gives us x squared is equal to 98, I believe. Yes. Okay. Again, we're going to take the square root, so we can get rid of the root and the square, and we get x is equal to the square root of 98. But we're not quite done yet, because we can break that down. We can simplify the square root of 98. So I'm going to break that down to 2 and 49. 2 is prime, 49 is not, so we're going to break that down to 7 and 7. And both 7s are prime. Okay, so we know to look for our pairs. So we have a pair of 7s and we have a loner 2. So we're going to say x is equal to, we're going to take one of those 7s from the pair out. And then we leave our loner 2 inside our radical. So we end up with our exact value being 7 root 2. The approximate value, it says round to the nearest hundredth. So we're going to take the square root of 2 in your calculator times 7. And that is going to give us 9.899. So since we're going to the nearest hundredth, we're going to this decimal place. Since we have a 9 here, that means that this rounds this 9 up. And since it rounds that up, it also rounds that 8 up. So we're going to have 9.9. But since it says to the nearest hundredth, you want to go ahead and put that hundredth place there. And so since we don't really have a number there, it's going to be a 0. Okay, so it's 9.90. And since, again, we have inches as our units, we can say inches for both of these. We can label. Okay, moving on to number 12. This one is actually very similar also to the ones that we just did. But this time we're talking about area. So we have an isosceles right triangle. And I don't know if you guys have heard of isosceles or not. But isosceles means that two of the sides are congruent, which means that our legs are going to have to, excuse me, legs are going to have to be equal or congruent. Okay, this sign right here, an equal sign with a little squiggly on top. I know that's not the technical term, but an equal sign with that little squiggly means that they are congruent or equal. Okay, so if we have a triangle and we have a right triangle, because it tells us isosceles right, then that means that our legs are congruent. So we're going to name them both X. And I'm just going to label them with an L for leg. We don't know the hypotenuse, but we're actually not going to need to know that, because it says the area is 18 square inches and it tells us to find the legs. Now, the area of a triangle is equal to 1/2 the base times the height. And the base and the height have to form that right angle. So they have to be perpendicular is what that's called. So they have to be the sides that form the right angle. So that means that we know the area is 18. So we're going to plug that in for area. We know 1/2, because that's just 1/2 is the universal thing that goes in for the area of triangle. And then we know the base is X. And we know the height is X. Okay, because we have our height. Let me show you here. We have our base and our height, because they form that 90-degree angle. Okay, so from here, we can figure out what we know. So we know 18. We know 1/2. And X times X is X squared. Okay. Now, really, if we say we had a 2 in front of that x squared, we would divide by 2. This time we just have a half, so we're just going to divide by 1/2 on both sides. And when you divide by 1/2, it's really like multiplying by its reciprocal, so multiplying by 2, which is going to give us 36 is equal to x squared. Again, we know how to solve this by taking the square root on both sides. The square root and the square cancel, and the square root of 36 is 6. It is a perfect square. So our answer is going to be 6 inches. Okay. Number 13, we're actually not going to use the Pythagorean theorem. We're just kind of, it's just a little tricky because this is the Pythagorean theorem unit or lesson, but we're not going to use that. So let's make a square. See if I can make it actually straight. Not too bad. Okay, so we have our square. And the area of the square is 48 meters squared. Now, the area of a square is the side length squared. Okay, so we have our sides, and they're all going to be the same. We've already talked about how a square has all congruent sides. Okay, and so if we know that the area of the square, so our A is 48, we can say 48 is equal to the sides squared. And we know how to solve this by taking the square root. So if we take the square root of 48 and of s squared, the square root and the square cancel. And so we get the square root of 48 is equal to s. Now, again, you always want to try to simplify. So here we can definitely simplify. We're going to break this down to, let's do 6 and 8. Then we can do 3 and 2. 3 is prime, so is 2. We can break down the 8 to 2 and 4. 2 is prime, 4 is not. So we break that down one more time to 2 and 2. And those are both prime. So now we look for our pairs. We have a pair of 2's here. We have a pair of 2's here. And we have a loner 3 here. So I take one from this pair, so one of my 2's from that pair, one of my 2's from this pair, and bring those both outside the radical, and then my loner 3 stays underneath the radical. So if I multiply my 2 times 2, I get 4 root 3 is equal to my side length. So each side length is going to be 4 root 3, and then we're talking about meters here, so we have meters. Okay, that is the side length. Now, perimeter is what it's also asking for, okay? And perimeter is the distance around a shape. So basically, that's saying, what is 4 root 3 plus 4 root 3 plus 4 root 3 plus 4 root 3, okay? We're adding up all of our side lengths together. So I'm going to just write that out real quick so that we know exactly what we're doing. And we know with adding radicals, they have to be like, and every single one of these radicals is like because they all have a 3 underneath the radical. So what we're going to do is we're just going to add up all of my outside numbers. So 4 plus 4 plus 4 plus 4 gives me 16. And then my root 3 stays the same. So 16 root 3 meters is going to be my perimeter around my square. Okay, we are actually going to do part A of 14, but we are not going to do part B. Okay, so let's look at 14. This one is actually a little confusing because it's just worded kind of weird. So it says, traditionally, televisions are advertised by their diagonal length. So what that means is whenever they tell you like it's a 52-inch TV, that means that they're going based on that diagonal. Okay. And they typically ratio of the length to width is 4 to 3. So a TV has length of 20 inches. So let's say our TV has 20-inch length, and 15 inches of the width, that side would be a 4:3 ratio. So the TV has length 4x basically, and the width is 3x. So if we have an advertised TV for part A with a length of 20 and a width, I'm sorry, it says what is the advertised size of a TV with length of 20 and width of 15. So that means that this side is also going to be 20, and that means that this side is also going to be 15, okay? Because we have a rectangle, a TV is a rectangle, and opposite sides are congruent. So we know a rectangle has 90-degree angles as well. So if you look here, that means that we're looking at a triangle and we're looking at a right triangle. So I'm going to draw that triangle out. Oops. Learning new things with my iPad here. It actually makes the line straight for you. There we go. So we have a right triangle. We have a side length of 15 and we have a side length of 20. And we want to know what that diagonal is going to be. So we can use Pythagorean theorem. We have a leg here, and this x is going to be our hypotenuse because it is across from that 90-degree angle. Okay, so we can just plug our numbers in. We have 15 squared plus 20 squared is equal to our hypotenuse squared. 15 is 225, or 15 squared, I'm sorry. 20 squared is 400, and that's equal to x squared. So we get 625 is equal to x squared. So if we go and we take the square root on both sides, our square root and our square cancel. And the square root of 625 is actually 25. So we get 25 is equal to x, which means if they were to advertise this TV, they'd say it is a 25-inch TV. Okay, like I said, we're not going to do B, so that concludes the Pythagorean theorem notes. So that was page 12. And that is all for Pythagorean theorem.